Okay, so today we're going to do day 4. Probability is a big topic. My pen is having a delay, so unfortunately I've had to fill all the answers in beforehand, and so I'll just take you through the explanations of those. All right, we start with a tree diagram. So just be pausing that video to familiarize yourself with the context. You can also pause and try to fill it out beforehand, as always. That's always a good habit to try it on your own, okay? But here, so we have flights. If we're filling this out, if this is 0.2, then this is going to be 0.8. And then probability does not arrive the luggage through direct is this. Hence, this is 99. Remember, these add up to 1. And then if it's a non-direct, the fact that the baggage doesn't arrive is slightly higher, of course, and then we can fill that in. Okay. So for part B, find the probability that Sarah's baggage arrives in London. So if you remember these, there's 2 ways that it can arrive, right? Either it can arrive direct or it can arrive non-direct. And so when you go, you just multiply across the tree diagram. So you have this, or you have non-direct and still arrives, okay? And so this is going to be your final answer. Now a little bit trickier. This is the conditional probability. Given that her baggage did not arrive, determine the probability that she flew direct. Okay, so this is your formula for the conditional. Remember, it's the probability of A given B. That's your given, so this becomes your denominator. So it's the probability that you have B as well as the A. So what you have and what you want. Okay, so we know that her baggage did not arrive. Okay, probability that it's direct did not arrive. Okay, the probability, what's the probability that it didn't arrive? Well, we found before the probability that it did arrive. So we're just going to do 1. Remember, that means 100% minus the arrival. So that's the probability that it didn't. So now what you're looking at is you're just looking at that it didn't, right? That's your sample space. Out of those, what's the probability that she flew direct? So it didn't arrive and it was direct. So it's this one, okay? So then you're going to go 0.8 and 0.01. Divide those out and you'll get this repeating, okay? Okay, so remember there were all these different probability distributions, so let's revise those. Okay, binomial. Extensive testing has shown that the probability of a piece of buttered toast landing butter side is down is 7/8. If you conducted 10 trials, determine the probability that the toast will land butter side down. Okay, what makes this binomial? Remember, binomial deals with discrete, right? Variables. So it's like number of shots that you took, and your probability stays the same. So you have the same probability of having an outcome from one trial to the next, and they're independent. Number of penalties that you take, or number of people that you choose, like this, okay? This is always the notation. So our variable is distributed with binomially with this many trials and this probability. So in our case, we're going to be doing 10 trials, and each time the probability is 7/8, okay? So then what we're going to do for that, in order to find it 6 times, is remember the probability that it's exactly 6 times. Maybe you remember this. We're going to go to probability, and when you want one specific outcome, you're going to go to density. Go to density, and then go to binomial. You can click the help button, and then it gives you total number of trials, probability, and the number of outcomes that you want, okay? So you're just going to hit 10, comma, and then the probability of success every time, 7/8, and you want exactly 6 trials, okay? And so there's your probability. It seems that I did not feel like writing it down or something. Okay, so 0.0.02, three significant figures, by the way, would need another 0 here. Okay, next one. At least 6 times. As soon as you hear this at least, what you want to be thinking of is you want to be thinking that this is not density now, but this is now going to be cumulative, okay? Because you're happy with 6 or 7 or 8 or 9 or 10, so a whole bunch of outcomes. So the probability that it's greater than 6 is you're going to go back to that probability button, and now you're going to go to cumulative. The distribution is still binomial, and then again n, and then 7/8, And now you're just going to go from how many you're happy with to how many you're happy with. So we're happy at least 6, 7, 8, 9, 10. And there's our probability, okay? So that's pretty high. So 2, that's like 1. I guess that makes sense, because if it's probability, if it's 7/8 of the time, it's landing down, but this is basically going to be, okay, this is really, really close to 1. Okay. 9, 5, and 5. So it's a really, really high chance you're going to get at least 6. Okay. Determine the expected number of times and the variances. You do have these formulas. So if you remember, the expected value is going to be n times p, and the variance is n times p times 1 minus p. Okay, remember variance is the squared of the standard deviation. Okay, you're just subbing it in. It's like, the average you're expecting. So 10, 7, 8. Then, out of 10, you're expecting about 87.75. And just leave it as that. It's an expected value. You don't have to like contextualize it, round it, just leave it exact. And then the variance, remember that's your spread. So 1 minus p, so 10 times p times 1 minus p. And that ends up being your variance. If you were to ask standard deviation, you would take the square root of this, okay? So that's binomial. Next one, normal. Again, if you want, pause, try this on your own. The nice thing is that with a normal, remember, you'll always be told that it's normal, okay? But the thing that you want to remember with a normal is it's always with continuous data. It's your height, it's your weights, it's your number of hours, it's your speeds, any sort of infinitely infinitesimal breakdowns. Okay, the runtime R of lithium batteries made by follows a normal distribution. Okay, so remember normal, this is always our mean, and then we always have a standard deviation. This is the way we write it, remember? So X is distributed normally with this mean and this variance. So this is how we would write it, even though what we really need is the standard deviation being 12. Okay, mean, easy, just look down the middle. There it is, it's 98, not a drama, okay? Standard deviation is 12. Find the probability that it's between this and this, so that it's between 85 and 100. Okay, what's important is it's always cumulative. Always. There's no density because it's a continuous variable. You can't have one specific outcome, okay? So in order to find this, we're going to go to probability, always cumulative with the normal distribution, okay? You can hit that help again. So mean, standard, from, to, okay? So we're going to go 98 and 12 and then 85 and then 100. Okay, and there's our answer. If you just want like less than 82, you can just type in, don't type in 0, you just type in 82 and leave it. If you want it from 82 to like infinity, then you type in 82. So you type in 98, 12, and then you type in 82 times a really big number. Remember that. Okay, the next part. The company states that 95% of the batteries have a runtime of at least n. Find the value of n. Okay, so 95 have at least n. So basically somewhere here, they have at least this value. And remember, these are actually probabilities. And so this is actually our, this is 95 and it's greater than some n. So what this is this is the inverse, okay? What makes it inverse, you are given the probability, you're given the area, and you need to find the actual bound now, right? So the actual number of hours. Okay, onto the calculator, probability, and then inverse, and then normal. And okay, so look at this. So mean, standard, probability. Small thing to remember. Remember the calculator thinks from the bottom up. So if you just put 0.95, it's going to give you the bottom 95% and it's going to give you something up here. But you in fact want this, right? Maybe you can see that actually if this is 0.95, then the remaining area is going to be 0.05, and that's what we want to tell the calculator. Okay, so instead of saying never mind. Okay. 98, and then 12, and then 1 minus 0.95. You can just type in 0.05, duh. Okay, 78.3. It should make sense. It should be some sort of low number, right? Because 95% of that area is more than that, okay? So that's normal for you. Always cumulative, lower and upper bound, and then this stuff is the inverse. Okay, next stuff, a little bit tricky. That was the distributions. Okay, distribution is when you're basically laying out all the probabilities, okay? When the game is fair, it means that your total expected value is 0. Okay, good. A biased coin has a probability of showing heads as 0.7. Jim pays $20 where he flips the coin. He gets no money, flips heads, and gets K. This game is fair. Okay, always define your variable first. So X here is the amount 1, right? So what can we have here? We can have here heads, or we can have here tails. Okay, he gets no money. The probability of him getting no money is 0.7. And then the other probability is that he wins K. So the probability of K is 0.3. So this expected value needs to be 20. So it's not 0 because he's paying 20 to win. So what we're going to do is we're going to go 0 times, remember, oh yeah. So if you look at the formula booklet, the total expected value for a whole distribution is always the sum of each x times its probability. Okay, so this is what we're going to do now. So we're going to do, okay, well, the probability of 0 is 0.7 plus probability of k times 0.3. If you insist on having the total outcome of 0, you can. What you can do then is you can just subtract 20. So when he won and paid the $20, then the total outcome is 0, like that, okay? Which is, of course, the same as if you were to go 0.07 plus k times 0.3 is equal to 20. So his winnings, like this is also fair, that his winnings end up being the same as what it cost him to play, okay? All right, so then this is 0, so you have so you have k times 0.3, so just divide 20, so k is going to be 20 divided by 0.3, and then divide that out, 0.3, and you have 66.67. Okay, so that's how much they're going to have to offer him to win in order for that game to be fair. Tricky. Okay, we're going to do 2 more. Like I said, it's a big topic. All right. So what are we given here? You're given, this is another probability distribution. And here, we don't know 2 of the probabilities, so we don't know the probability, whatever, say it's 4-sided die, tetrahedron. You don't know the probability of rolling a 2 or a 3, but you know the total expected value. Whenever there's 2 things you don't know, you know that you won't be able to solve that with one equation. So what you can do is, one of the equations you can solve is, you know the total probabilities, all of them split up like that, will equal to 1. So you can easily make an equation of a plus b plus 0.3 plus 0.2 is 1. If you bring those on the other side, subtract from both sides, a plus b is 0.5. And then another equation you can make is, of course, the expected value. So remember the formula I just showed you. So that's going to be the sum of each x times its probability. So you're going to go this times this plus this times this plus this times this plus this times this, and that'll give you the expected value. A little bit of algebraic manipulation. You can pause and just look at my algebra here. Collecting like terms being 1.1, subtracting it from 2.5, you end up with these two equations. And so now what we can do is you can, of course, solve them algebraically, or you can also just go to linear solver. So in front of the A is 1, in front of the B is 1, and this is 0.5. And then the other one is 2 and 3 and 1.4. Okay, there's your result. So your A is 1, your B is 4. You could, of course, substitute these back in, right? And then multiply them out and see if you get the expected value. And, of course, 0.1, 0.4, all of these should also add up to 1, so you know you're correct. All right, last one. Okay, so another aspect of probability is like, dealing with these tree diagrams with one, and then Venn diagram is another way to represent the information. Okay, a group of students at Doon High School, they were asked which of the following products, okay? What you can do is you maybe don't look at mine, but just pause it and see if you can break this apart, okay? Where do you start with these? So you want to draw the 3 overlapping circles, and then I started from the bottom, and the bottom one, I of course forgot, yay, I was in a bit, I was Russian, ha ha ha, okay. So none of these products, right? Then books only, so check, there's the 8. 40, all 3 products, there's your middle. Okay, so 50 films and books. So that means that it doesn't say films and books only. So this is not 50. This is your films and books, right? All these people have books and books. So this is already 40. You fill it up with 10. Next one, books and music. In total, again, you have 52. Since that 40 is in there, this has to be 12. Good. 68 download film and music. 68, you have that 40, so that becomes 28. Okay, now 95 downloaded films. Do not put 95 here. Remember, this is everybody who downloads films, so all of this should be 95. So you can go 95 minus this, minus this, minus that, and you'll get 17. 50, 78, yeah, 17. Okay, and then you have in total 100 music. You already have these, and you can see that these add up to 40 and 40, 80, and so the other last ones are 20. Okay, calculate the total number, calculate the number of students surveyed. Just add it all up. You should, I don't know why I didn't feel like putting down the answer, but you should end up with 160, okay? All right, so now these things on your Venn diagram shade. So what does this mean? This means film or music. And not books. Okay, so let's just see. So film or music, film or music, that's all of, film or music is all of these people, right? Film or music. Remember what or means. Or means that it's A or B or both of them. So anything that fits film or music you're happy with. So that means that it's this, that means that it's this and this and this and this and this. But it can't be books, okay? So it has to be and not books. Okay, so this is film or music, but not books, so avoid books. I can't believe I just said avoid books. It's terrible. Don't avoid books. Yeah, okay, so the or just means take anything that fits. The and means you must exclusively leave this out. Okay, so then we end up with, if you add this up, 48, 58, 65. Yeah, that's fine. Okay, the probability that student downloaded music. So now you're looking at all the music, and that ends up being 100 out of the total. This again is our conditional. Student downloaded books, given that they had not downloaded films. So there's the formula. Remember, so given that they did not download films, so books but not films, so your sample space becomes everything that does not include films, which is of course this, and this. So what's that? 20, 40, 65, right? Yes, Ms. Walsh, correct. And now out of these, where are the books? Here. So there's the 20. A student downloaded at least 2 products. Okay, we'll just go one by one. Everything in here is like, this is 2, this is 2, this is 2, this is all 3. So you just want the sum of these, right? This is 40, 40. What is this, 90? Yes, it is. Good. Okay, last bit, almost done. Dune Canyon High School has 850 students. Find the expected numbers. Remember, that's N times P that downloaded music. So take your probability of music. So that's your P and multiply it by the total number of students. In this case, we are just going to round it to the nearest whole student. Okay, so that's a quick drive through probability. Okay, probability distributions are important. Normal is important. Binomial is important. Conditional probability is important. Yeah, everything is important. Okay, you've got a little bit of reminders here as well on where to go in the buttons with some examples. This is now in your day 4 exercises. I didn't really go through mutually exclusive events. Those are the ones that can't happen at the same time. This would now be on your worksheet. Yeah, the one that you're going to go to and do the exercises. Mutually exclusive is like the probability of you being in math right now and the probability of you being in English right now. That can't happen at the same time. Independent just means that they have nothing to do with each other. So the probability of Anna coming to school and the probability of Bob coming to school, okay? So you just multiply them. It's like tossing a coin and rolling a die. They don't affect each other, right? Okay, so on with it. Good luck.